This video is going to show you how to do the for every method of solving problems where we need to go from a mass to a number of particles. So the first thing we need to do is write our for every statement. So I know for every 1 mole of zinc, there are 65 grams, and I get this from my periodic table. So 1 mole of zinc, there are 65 grams. And I also know, because it's 1 mole, that I have 602 sextillion particles, or 6.02 times 10 to the 23rd particles. And I'm just going to abbreviate it because it makes it easier for me. Okay, so when we're doing our for every statement with this, technically I have 3 different variables in my for every statement, but I only can focus on 2. So I'm going to focus on grams, and I'm going to focus on number of particles. So I know, again, from my for every statement above, for every 65 grams, there are 602 sextillion particles. And in the problem we're given, we have 104 grams. So when I look at this, I know that I have a greater mass, so I'm also going to have a greater number of particles. So I'm going to divide 104 by 65 to figure out what 65 was multiplied by, and I get 1.4. So the 104 is 1.4 times bigger than 65. So I'm going to also multiply 602 times 1.4. When I do that, I get 963 sextillion particles of zinc. Or if you're doing it with scientific notation, it would be 9.63 times 10 to the 23rd. Okay. For this problem, we're going to use the exact same for every statement. So for every 65 grams of zinc, there are 602 sextillion particles, or 6.02 times 10 to the 23rd particles. And in this problem, we are given 271 sextillion atoms. So 271 sextillion. And remember, atoms are the same as particles. So if I look at this, I notice that it got a lot smaller. So I have to figure out what factor was 602 multiplied by to get 271. So I'm going to do 271 divided by 602, and I get that it is 0.45 times smaller. So that tells me I also have to multiply 65 times 0.45 to make this 0.45 smaller. When I do this, I get an answer of 29.3 grams of zinc.